So today we're going to be looking at how do we graph rational functions. A rational function is just a fractional function. So this would be a rational function. See how it's got a numerator and a denominator. So we will be finding intercepts, asymptotes, and we'll also be using limit methods to graph rational functions. How do we find an x-intercept? Well, if we have any kind of function, maybe it looks like this. This right here is going to be the x-intercept. And that means when y is 0, what is x? So to find an x-intercept, we plug in 0 for y and solve for x. If we want to find a y-intercept, well, let's say this function goes over a little bit further and hits the y-axis right there. Well, that would mean to plug in 0 for x and solve for y. So that's nothing new. You've done that, x and y intercepts. Okay, now, when we've been finding on that worksheet, every time we found a limit as x approached infinity or negative infinity, we were actually finding a horizontal asymptote without realizing it. You can do this. You can find those limits as x approaches infinity to find your horizontal asymptotes, or you can use these rules if you want to memorize these rules. The rule is this: if the numerator and denominator have equal degrees, then the horizontal asymptote is going to be y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Let's go to this one. This would be that kind of situation. The degree on the top is 1, the degree on the bottom is 1. So to find this horizontal asymptote, I could use this rule, where it's going to just be a over b. But if you get into a bind and you're just not sure, here's what you can do as well. You can find the limit as x goes to infinity of this. So to find that, I would divide by the highest power of x in the denominator. So I divide this by x and I get negative 6. I divide this by x, and divide that by x. What happens now if I plug in infinity? What's 6 over infinity? And what's 2 over infinity? So I'm going to have negative 6 plus 0 over 1 over 0. And what do I get? Negative 6. And wouldn't that be the same thing I would get as if I had just used the rule? See how the rule says that if the numerator and denominator have equal degree, the horizontal asymptote is just going to be a over b, okay? So whichever one of those two you want to use. Okay, number 2, it says if the denominator degree is greater than the numerator degree, then the horizontal asymptote is y equals 0. The degree of this denominator is 1. The degree of this numerator is 0. So therefore this degree is higher. So what should the asymptote be, the horizontal asymptote? It should be 0. So now let's check it with our limit. The limit as x approaches 0. I would go ahead and divide by x. So I'm going to have negative 2 over x. X over x is 1 minus 4 over x. Oops, I meant infinity. So if I plug in infinity now, what's negative 2 over infinity? 0. And then 4 over infinity. So I'm going to have 0 divided by 1, which is just 0. So now we know that these asymptote rules, they do work, okay? So you can do whichever you want, like I said. Either find these limits to find your horizontal asymptotes or know these rules. All right, so now we're going to do this for all of these functions. Our goal is to be able to graph these. We want to find x and y intercepts, holes, horizontal asymptotes, vertical asymptotes. Use one-sided limits to evaluate the limit as x approaches a vertical asymptote. And we're also going to sketch. Okay, so to see if we have vertical asymptotes, that's going to be whatever x value makes the function undefined. In other words, makes the denominator equal 0. So what's it going to be in this case? 4. So x equals 4 is our vertical asymptote. So let's go ahead and graph that. We already said earlier that the horizontal asymptote is y equals 0, so let's graph that. Holes in the graph are only going to be if a factor in the denominator and numerator cancel. They do not, so there are no holes in the graph. X and y intercepts. I'm going to plug in 0 for x, and this is going to tell me the y intercept. So if I plug in 0 for x, what do I get? 1/2. Good. So let's graph that, plot that point. Okay, now I'm going to set the function equal to 0. I'm going to plug in 0 for y. If I cross multiply, I'm going to get -2 equals 0 times anything is 0. So that right there, because it's nothing to solve, there's not going to be any x-intercept. So what that tells me is that the function is not going to cross the x-axis. It's not going to cross the horizontal asymptote. It can cross it. A function will never cross the vertical asymptote, but sometimes it will cross that horizontal asymptote, but not in this case because we don't have an x-intercept. There's never a time the function equals 0. To finish this up, I need to know what's going on with the function. How does it look? So what is the limit as we approach that vertical asymptote from the left? Well, I can't plug in 4, but I can plug in 3.99. So I'm going to have -2 over 3.99 minus 4. All I have to do, I know the answer has to be positive or negative infinity. Is this answer positive or negative? Positive. So therefore I know it's going to be positive infinity. So as we approach 4 from the left, the function has to approach positive infinity. That's the way it has to look there. Don't make this zoom up. It kind of should be leveling out. Okay, as we approach 4 from the right. So now I'm going to plug in positive 4.01. So I'm going to have a negative on the top. 4.01 minus 4 is a positive. All I care about is it positive or negative? What's it going to be? So it's going to be negative infinity there. So I know that it can't cross this, it can't cross this, so therefore it's going to have to look like that. Okay? So that's our goal. On example 2, vertical asymptotes. Well, first I want to factor the numerator. If I factor the numerator, I'm going to get -6 times x minus 1. Okay, there's still no hole in the graph. There's nothing that's going to cancel out. So the vertical asymptote is going to be what? So x equals -2. Go ahead and plot it. There were no holes in the graph. To find the asymptotes, I'm going to plug in 0 for x. Let's just go back to the original. If we plug in 0 for x, what are we going to get for y? 3. So 0, 3 is going to be our y-intercept. To find the x-intercept, I have to set y equal to 0. If I cross multiply, I'm going to get -6 times x minus 1 equals 0. So I can divide both sides by -6. So x equals 1. That's going to be my x-intercept. Our horizontal asymptotes way down here at -6. Okay. I still am not sure. See, I know what this part looks like because I have these 2 dots. So I know it's going to look like this here, but I'm not sure here. It could look like this or it could look like that. So we will go ahead and find the limit as we approach -2 from the left. So I'm plugging in -2.01. So when I plug that into the top, I'm going to have a -6, that's negative. -2.01 minus 1 is negative. -2.01 plus 2, that's negative. So what's this going to end up being if I have a negative times a negative divided by a negative? Negative, so it has to be negative infinity. I know it has to be one of the two. I can never cross the vertical. It could cross the horizontal, but most likely it doesn't, unless it could equal -6 for some x value, and it can't. So it's going to look like that. And then just to double check, I'm going to do -1.9, plugging that in. I get a negative times a negative divided by a positive, and so that's going to be positive infinity, and so we're going to look like this. Okay? Questions? Just putting it all together. All right. Next one, here's our function. I have to factor the denominator. Okay, now this time those two cancel. So we only have one vertical asymptote, and what is it at 4? The hole in the graph, well, whatever canceled out, that's where the hole is. So what would make that be 0? -4. So there's going to be a hole in the graph at -4, comma. Now you need to plug that back into this part to see what the actual point is. So if I plug -4 in here, I'm going to get 1 over -8. So this is where the hole in the graph is going to be. Just kind of putting that in there. Horizontal asymptote, the power's higher on the bottom. So what's the horizontal asymptote? 0. Or you could find the limit. X and Y intercepts, I plug in 0 for X, and I get -1/4 for Y. Plug in 0 for Y, cross multiply, I get 1 equals 0, no X-intercept. Okay, so what that tells me then is that it's never going to cross that horizontal asymptote for sure. So therefore I know this part's going to have to look like this. This part, I should find a limit just to be sure. So I have to find the limit as X approaches 4 from the right side. I'm going to plug in 4.01. I would end up with a positive because 1's positive. 4.01 minus 4 is positive. That's positive infinity, so I know for sure it has to go up like this. Now this is an extra question. It's asking me for the limit as X approaches -4. What's that going to be? As we approach -4. Plug it in, what do you get? 1 over, plug in -4, what do you get? -1/8, right? Isn't that where we have that hole in the graph? Remember, we still have a limit if there's a hole in the graph because it's just what we're approaching. So that's going to be our limit right there. All right. The end of this is just review. I want you to take a look at those and do those on your own. That's some of those types of questions will be on your exam. So do those right now. Then I'm going to pass out your worksheet for tonight. All you have to do are the odds. Tomorrow in class we'll be going over the exam review, and I'll also give you some time to finish this worksheet. All right, so let's hear what you got on these. Megan, what did you get on A? Say it again. 13. Do we agree with 13?
Yeah.
13 is right. We're approaching from the right, or left rather. So from the left, we do the less than, and that's going to be the answer we would get. Okay, what about letter B? What did you put there, Will?
0.
0, do we agree with 0? Good. We're approaching from the positive side, which is the greater than side. Plug it in, you get 0. What about letter C? Olivia Lorenz, what did you put? Do we agree with 0 for that one? Some people are saying no. Stephanie, why do you disagree? Yes, the limit does not exist here. Because in order for this to have an answer, the limit from the left and the limit from the right would have to be equal. If they're not equal, then the limit does not exist. And it means there's a non-removable discontinuity there too. Find G of 4. That means when you plug 4 in, where do you plug it into? Blake, what do you think? Not sure? Anybody know? Where would you plug in 4? Where's it equal? In the top or the bottom? Bottom, so it's negative 4 plus 4? 0, so this should be 0. Discuss the continuity of g of x. Well, I look here. Is a line always continuous? Yep, so both of these are lines, so they're always continuous. The only place they may not be continuous is at 4. So what did you put, Faith, for this one? Say it again. Is it removable? Is it just going to be an open dot? Or are these too far away? Non-removable. So it's a non-removable discontinuity at x equals, and what's the x value, guys, that causes us to have that? 4. Everywhere else it's continuous except for at 4. Okay? All right, very good.